Hi everyone, this is Group 9 and my name is Pawanjit. These are my group members, Chin Iwan,
Hi.
Liang En,
Hi there.
Ng Wen Jin.
Hello.
Today we are going to talk about nanotechnology. Liang En, can you please tell me what is nanotechnology?
Well, nanotechnology is a development of substances or gadgets using the properties of nanoparticles. So the size of a nanoparticle is 1 nanometer to 100 nanometer. So this is a diagram which explains some examples of the size of nanomaterials. So the field that is included in nanotechnology is semiconductor electronics. Well, semiconductor electronics have interesting physical and chemical properties and useful functionalities. Narrow and intensive emission spectra, continuous absorption by bands, high chemical and photo bleaching stability. Processability and surface functionality are among the most attractive properties of these materials. The development of nanochemistry is reflected in an immense number of publications on the synthesis of semiconductor nanoparticles. Parameters such as size, shape, and surface characteristic can be varied to control their properties for different applications of interest. These novel properties of semiconductor nanomaterials have attracted significant attention in research and application in emerging technologies, such as nanoelectronics, nanophotonics, energy conversion, nonlinear optics, miniaturized sensors and imaging devices, solar cells, catalysis, detectors, and photography, biomedicine. So for electronics and IT application, nanotechnology has greatly contributed to major advances in computing and electronics, leading to faster, smaller, and more portable systems that can manage and store larger and larger amounts of information. For example, computer uses MRAM, magnetic random access memory, so it will be able to boot almost instantly. The characteristics of nanotechnology in electronics and IT applications are flexible, bendable, foldable, rollable, and stretchable electronics. They are reaching into various sectors and are being integrated into a variety of products, including wearables, medical applications, aerospace applications, and the Internet of Things. Flexible electronics have been developed using, for example, semiconductor nanomembranes for applications in smartphone and e-reader displays. Making flat, flexible, lightweight, non-brittle, highly efficient electronics opens the door to countless smart products. Nanoparticle copper suspensions has been developed as a safer, cheaper, and more reliable alternative to lead-based solder and other hazardous materials commonly used to fuse electronics in the assembly process. So for electric and energy, nanotechnologies provide the potential to enhance energy efficiency across all the branches of industry and to economically leverage renewable energy products through new technological solutions and optimized production technologies. Energy sources, nanotechnologies provide essential improvement potential for the development of both conventional energy sources, such as fossil and nuclear fuels, and renewable energy sources like geothermal energy, sun, wind, water, tides, or biomass. Nano-coated wear-resistant drill probes allow the optimization of lifespan and efficiency of systems for the development of oil and natural gas deposits or geothermal energy, thus the saving of cost. For energy conversion, electricity, regarding the reduction of energy losses in current transmission, hope exists that the extraordinary electric conductivity of nanomaterials like carbon nanotubes can be utilized for application in electric cables and power lines. Furthermore, there are nanotechnological approaches for the optimization of superconductive materials for lossless current conduction. In the long run, options are given for wireless energy transport through laser and microwaves or electromagnetic resonance. Future power distribution will require power systems providing dynamic load and failure management, demand-driven energy supply with flexible price mechanism, as well as the possibility of feeding through a number of decentralized renewable energy sources. So finally, for agriculture, advances in agriculture are always being made to ensure that the food output can meet the needs of an ever-growing population. As general class of materials, the aim of using nanotechnology in the agricultural sector is to reduce the application of plant protected by products, minimize nutrient loss during fertilization, and increase the yield of crops by optimizing their nutrient intake. There are also many different sub-applications for nanotechnology in agriculture. For example, these include using nanomaterials in biochemical sensors to detect the interactions between enzyme and foodstuffs. The development of nanocapsules which provide an effective controlled delivery of fertilizers, pesticides, growth hormones, and other agri-chemicals to specific sites of interest to prevent the over-application of agri-chemicals. There are other examples of nanotechnology in agriculture, which is nanosensors, which can monitor the conditions of the soil and the growth of the crops, nanochips, which can be used for identity preservation and tracking of crops, and the development of nanoparticles which are designed to deliver DNA to plants. And that is all.
The properties imparted to textiles using nanotechnology include water repellent, soil resistant, wrinkle resistant, antibacterial, anti-static, and UV protection, flame reduction, improvement of dye ability, and self-cleaning fabrics. Nanotechnology applications in the food industry can be utilized to detect bacteria in packaging or produce stronger flavor and color quality. One application of nanotechnology in medical currently being developed involves employing nanoparticles to deliver drugs, heat, light, or other substances to specified types of cell. Nanotechnology application in cosmetic includes sunscreen that uses zinc oxide nanoparticles to block ultraviolet rays while minimizing the white coating on the skin. Sunscreen that uses nanoparticles generated by eye buds.
Okay, so the nano material that can be found in my house is this submiller beer bottles. This submiller is actually a beer brewing company. It incorporates flaky clay nanoparticles in its plastic beer bottles. These tiny clay particles fill up more space in the walls of the bottle than plastic nanoparticles, and they make it difficult for gases to escape or enter the beer bottle, ensuring that it retains the optimal flavor longer. How about you, Ian?
Ian, your mic.
Sorry. There are also sport equipments that uses nanotechnology, such as this racket, which Babolat, a French tennis racket manufacturer, launched a racket with carbon nanotubes, which delivers a better torsion and flex resistance. The rackets are sturdier than present-day carbon rackets and pack more power. Tennis balls are manufactured by coating the inner core with clay polymer nanocomposites to make them last longer. These tennis balls, manufactured by the company InMat, have twice the lifetime of conventional balls.
NanoGlue is a proprietary adhesive promoter that is designed specifically for improving the bonding and durability of adhesive and top coats and to glass substrates.
Bandage, incorporating novel metals which have natural antimicrobial properties into bandage has been proven to help combat bacterial infections. Since silver disturbs the growth of bacteria by blocking its metabolism, creating bandage with silver nanoparticles woven into them. These bandages are commonly used to dress injuries that are resistant to treatment and prone to infections like burn wounds.
Nano sunscreen are those containing zinc oxide and titanium dioxide. There have been sunscreens of old which made up of big particles that made them efficiently reflect ultraviolet rays. Nanoparticles are much smaller. A nanometer is a billionth of a meter and behave differently. Even when they clump together, they still appear transparent on skin.
Wenjing, what is graphene?
So graphene is an allotrope of carbon consisting of a single layer of atoms arranged in a two-dimensional honeycomb lattice nanostructure. The name is derived from graphite and the suffix "in" reflecting the fact that the graphite allotropes of carbon contains numerous double bonds. The size of graphene measures from 0.1 nanometer, which makes graphene among the most important materials in nanoscience and nanotechnology.
Then Wenjing, what is the physical properties of graphene?
The first physical properties of graphene is that the graphene is transparent and absorb only 2.3 of the reflected light. Furthermore, the graphene is thin and light. It is found as the thinnest substance, which is one atom thick, around 0.34 nanometer, and it is found as the lightest substance as well. It's roughly 0.77 mg each meter cube. And it is strong and hard as well. Monolayer graphene is considered to be the strongest material ever tested with a strength of 42 Newton per meter, and it is much harder than either steel or diamond of the same dimension.
It is elastic too, more elastic than rubber. Most structurable crystal can stretch up to 20% of its initial size without breaking it. Impermeable. Even the smallest atom, helium, cannot penetrate a single layer of graphite. It is also a good conductor of heat and electricity. Graphene conducts heat in all directions. It is an electropotic conductor. Graphene has extremely high electrical current density, 1,000,000 times that of copper, and intrinsic mobility 100 times that of silicons.
Yes. And do you know any chemical properties of graphene?
Yes, chemical properties of graphene is movement of its electrons are rapid. The most reactive carbon electrodes burns at low temperature. Graphene sheets burn at low temperature than graphite. The chemical exfoliations and oxidizing of layered crystalline graphite produce graphene oxide, which is used as catalyst.
Interesting. What can graphene be used for?
Well, actually, graphene can use as electronics. The arrangement atoms in graphene enable it to be a supervised conductor. Graphene's remarkable conductive strength and elasticity has also made it a promising choice for stretchable electronics, a technology that aims to produce currents or flexibilities plastic substrates for applications like bendable solar cells or robotic like artificial skin sensors. Graphene has high surface area. Already, researchers have shown that the distinctive 2D structure of graphene oxide, GEO, combined with its super permeability to water molecules, leads to sensing device with an unprecedented speed. Example of graphene is biomedical, such as sensors, tissue engineering, medical, delivery system. The optical image of graphene wireless sensors biotransfer onto the surface of the tube.
Moreover, graphene can be used for polymers and composites because high mechanical strength makes graphene suitable for polymer composite materials. And it can be used for graphene membrane, such as water filtration, for example, for desalination purposes, industrial gas separation, such as carbon dioxide capture, large-scale energy storage system, and the graphene act as separator membranes for redox flow batteries. And it can also use as filtration membrane in the food industry, such as filtering lactose from milk. And graphene can be also used for energy. Graphene improves both energy capacity and charge rate in rechargeable batteries. Activate graphene makes supercapacitors for energy storage. Graphene electrodes may lead to a promising approach for making solar cells that are inexpensive, lightweight, and flexible. Okay, so that's all for our speech today. Thank you for your attention.